This video is an introduction to advanced manufacturing and cybersecurity. This video was brought to you by the National Cybersecurity Training and Education Center out of Whatcom Community College. NCyTE Center and this material is based upon work supported by the National Science Foundation. My name is Philip Kreger. I'm a professor of cybersecurity at Embry-Riddle Aeronautical University in Daytona Beach, Florida. As an overview to our discussion today, we'll first discuss manufacturing as a critical infrastructure sector according to the Department of Homeland Security. We'll define the term advanced manufacturing. We'll discuss modern, digitally driven manufacturing. We'll define operational technology and how it differs from information technology. And finally, we'll discuss the need for the convergence of IT cybersecurity and OT cybersecurity. So the Department of Homeland Security has designated 17 critical infrastructure sectors. One of these is manufacturing. The critical manufacturing sector is crucial to the economic prosperity and continuity of the United States. A direct attack on or disruption of certain elements of the manufacturing industry could disrupt essential functions at the national level and across multiple critical infrastructure sectors. The Department of Homeland Security has identified 4 primary sectors within the critical manufacturing sector. These include primary metals manufacturing, which includes things such as iron and steel mills and ferroalloy manufacturing, aluminum production and processing, and non-ferrous metal production and processing. Additionally, machinery manufacturing, which includes engine and turbine manufacturing, power transmission equipment manufacturing, earth-moving, mining, agricultural, and construction equipment manufacturing. Also, electrical equipment, appliance, and component manufacturing, which includes electric motor manufacturing, transformer manufacturing, and generator manufacturing. And finally, transportation equipment manufacturing, which includes vehicles and commercial ships manufacturing, aerospace products and parts manufacturing, and locomotives, railroad, and transit cars, as well as rail track equipment manufacturing. Now, these all fall under the rubric of something called critical manufacturing, but what is advanced manufacturing? Advanced manufacturing involves the use of automation technology to improve products and processes. For example, robotics, sensors combined with automation and robotics, computer-aided design, computer-assisted manufacturing, and 3D printing. So in the past few years, manufacturing has moved from analog, such as manual labor and paper and pencil design, to being digitally driven. Networks of computers, automated machines, as you saw previously, ubiquitous sensors, and technicians whose job is to convert digital data into physical parts and assemblies. Design, manufacturing, and product support operations are driven by this digital thread of technical data, product and process information that can be shared throughout the supply chain and that must be protected. Much attention has been given to protecting technical information and information technology systems and networks, and that's really why we're studying information technology and cybersecurity. But protecting the operational systems of a manufacturing enterprise presents a new and different set of challenges. Not only must the technical data be protected from theft, it must also be protected from alteration that could impair the proper functioning of parts produced or affect the safety and availability of the production system. Cyber threats to manufacturing may be motivated by espionage, financial gain, or other reasons to compromise data confidentiality, integrity, or availability of data, products, or processes. Now, these videos were created for information technology or cybersecurity students, so just to make sure we're all on the same page, we're going to go over elements of information to protect, and that's specifically what we call the CIA Triad: confidentiality, integrity, and availability of information. So first, confidentiality involves limiting system and information access to authorized users and for authorized purposes only. Integrity involves ensuring information and systems are not modified by unauthorized users and that the systems function as they were designed. And finally, there's availability, which involves ensuring information and services are available to authorized users when they are needed. Now let's apply these concepts to operational technology and the manufacturing process. Confidentiality may mean the theft of technical data, including critical national security information and valuable commercial intellectual property. integrity, the alteration of manufacturing data, thereby altering processes and products, resulting in products not as specified in designs and potentially causing safety or availability issues, and availability in the impairment or denial of process control, thereby damaging or shutting down the operations of the manufacturing process. Up till now, a lot of what we've talked about in previous videos was really dealing with information technology. However, now we have to expand our thoughts to operational technology of cyber-physical systems. Business information technology cybersecurity needs are not the same as manufacturing operational technology cybersecurity needs. Within the context of manufacturing, operational technology, OT, includes computer systems that are designed to be deployed in critical infrastructure such as power and water, manufacturing, and similar industries. OT automates, monitors, and manages the operations of industrial machinery using custom protocols and software to communicate with legacy systems and proprietary systems. Now, a legacy system is usually an outdated computing software and or hardware that is still in use. The system still meets the needs it was originally designed for, but doesn't allow for growth. A proprietary system is a technology or a system that is a combination of processes, tools, or systems of interrelated connections that are the property of a business or individual, so they've been individually created by an enterprise or individual to meet their own needs. These technologies are much different than what we normally discuss in IT and cybersecurity, where we have common operating systems such as Windows or Linux or Mac OS, and hardware such as workstations, PCs, laptops, and routers, all of which are expected to integrate easily and to continue to be updated and replaced as needed. And now you've probably got kind of a sense of what operational technologies are, is because they're the combination of cyber and physical systems. And a cyber-physical system integrate sensing, computation, control, and networking into physical objects and infrastructure, connecting them to the internet and to each other, much like you saw before with the robotics. Before we go any further, there's other terminology and technologies that we need to discuss and define so you understand how different operational technologies are than what you've probably studied before. First off is supervisory control and data acquisition systems, or more commonly called SCADA. SCADA systems are systems of software and hardware elements that allows industrial organizations to control industrial processes locally or at remote locations, to monitor, gather, and process real-time data, to directly interact with devices such as sensors, valves, pumps, motors, and more through human-machine interface software, and to record events into a log file. We also have industrial control systems, which is an information system that's used to control industrial processes such as manufacturing, product handling, production, and distribution. Industrial control systems include supervisory control and data acquisition systems, SCADA, used to control geographically dispersed assets, as well as distributed control systems and smaller control systems using programmable logic controllers to control localized processes. Which leads us to programmable logic controllers, which are a solid-state control system that uses a user-programmable memory for sorting instructions for the purpose of implementing specific functions such as input-output control, logic, timing, counting, communication, arithmetic, data, and file processing. And finally, at the most specific level, we have sensors. A sensor is a device that measures a physical quantity and converts it into a signal which can be read by an observer or by an instrument. A sensor is also a device which responds to an input quantity by generating a functionally related output, usually in the form of an electrical or optical signal. SCADA, industrial control systems, programmable logic controls, and sensors are all the heart of operational technologies. The graphic you see on the screen delineates the difference between the information technology zone, as you see at the top, and the operational technology zone at the bottom. At one point in time, those were separated. And it's only in the last few years, the last couple of decades, that those have started to be integrated into one another. And recall that the enterprise IT is something that's going to be connected to the internet. Well, a few decades ago, there was a segmentation between the information technology and the operational technology zones. So the operational technology zones, where we had the cyber physical systems, were in no way connected to the internet. But now in many areas they are, which leads us to a cybersecurity and operational cybersecurity problem. The National Defense Institute Association indicated that factory floor technology includes networks, servers, and endpoint computers, but it also includes these cyber physical systems we've discussed, where network machines, sensors, and software combine to produce physical changes in materials, parts, and environments. As you see on the right, we see a series of robots manufacturing devices. Moreover, the industrial control systems that control these processes typically run specifically designed operating systems and communications protocols, what we discussed before with regards to the legacy systems and the proprietary systems. Now, these handle real-time processing and synchronization needs. They have a lifetime on the order of 15 to 20 years and are rarely rebooted or stopped to install patches. They depend on network sensor feedback and can have catastrophic physical safety consequences if they are compromised. So if we go back and dissect that paragraph, we'll notice a few things of how those systems differ from our common information technology systems. These systems have a very long lifetime, from 15 to 20 years, and normally the lifetime of a computer in business and enterprise is going to be about 3 to 5 years. They're also consistently having to be patched, and the reason is that these systems, the enterprise IT systems, are connected to the internet. Therefore, they need to be patched for security reasons. So as we see, the operational technology and the cyber physical systems that are used in advanced manufacturing clearly operate differently and have different needs with respect to cybersecurity than our IT systems. So while cybersecurity is deeply ingrained in the what we call information technology culture, operations technology focuses on safety and availability of factory systems for production output. So this graphic does a good job of delineating the segmentation of the IT infrastructure and the operations technology infrastructure. On the top, you have the enterprise systems, our normal IT systems for which we apply our controls for cybersecurity, and in the bottom, we have our operations technology infrastructure, which is comprised of SCADA, programmable logic computers, and sensors, and then right down at the machine level. And notice there that they are connected, is that the modern operational technology systems are going to be connected due to various reasons, including geographical distribution, to the enterprise level systems which are used to control the operational technologies. Again, operational systems often run legacy software, making them more vulnerable to compromise, and that intrusion can render them unable to meet their production high availability requirements. For this reason, OT systems, while connected to a network, were at one time they were air gap from IT networks and the public internet. And if you're not familiar with the term air gap, this is essentially what it means. Essentially, it means that these systems were not connected to the public internet. And as you see there, the OT infrastructure is not connected to the enterprise systems. However, in the modern age of advanced manufacturing, you will have that connection between the IT infrastructure and the OT infrastructure, allowing for the control of the processes and the production to occur from geographically dispersed areas. With the introduction of something called the Industrial Internet of Things, or IIoT, the IT-OT air gap is rapidly dissolving. IIoT devices enable industrial processes to be remotely monitored and managed from a central location, allowing organizations to achieve greater efficiency and productivity. But with that convergence and with the dissolving of the air gap, there comes all the problems that we already have identified associated with IT and cybersecurity and all the enterprise systems that are connected to the public internet. Because now any attack or threat in the IT zone, given that there is no air gap, given that there is a connection between the IT zone and the OT zone, those threats and those attacks now can filter down to the operational technology zone. So they can affect the SCADA systems, the industrial control systems, the programmable logic computers, as well as the sensors. Now that was a quick introduction to advanced manufacturing and in particular defining the difference between information technologies and operational technologies. Understanding now with advanced manufacturing, you have these things called cyber physical systems, and that these systems can be based upon legacy software, legacy hardware, and proprietary software and hardware. And therefore, the needs for operational technologies in advanced manufacturing are probably going to be different, are going to be more diverse than in what we normally think of with information technology. But in the next video, what we'll talk about is the cyber threats to operational technology in manufacturing. We'll discuss actual incidents of cyber attacks on operational technologies. We'll discuss the merging of IT and OT cybersecurity. And finally, we'll discuss risk mitigation strategies and controls for cybersecurity in manufacturing. This video was brought to you by the National Cybersecurity Training and Education Center out of Whatcom Community College.